lesson, we're going to look at properties of log functions. So remember, we have two types of log functions. We have what's called the common logarithm and then the natural logarithm. The difference is the common logarithm is any logarithm with base 10. So any log with base 10. So this looks like log of x or log base 10 of x. So these two things are equivalent. The reason why we call it the common logarithm is because commonly we use base 10, but because it's the common logarithm, you don't always have to write the base. So basically, if you don't see a little subscript with a number, that's assumed that the log is base 10. So these two things are equal. Same with the natural log. The only difference is with the natural log, this is the inverse of the exponential function e to the x. So this is any log with base e. So this one looks like ln of x, which is the same thing as saying log base e of x. So again, it has its own notation. So its own notation here looks like lnx, and the common log looks like log base 10 of x, which is just log of x. Otherwise, if it's not one of these two, then it'll have this format, log, and then it'll have some other type of number. So log base 10 comes from 10 to the x. It's the inverse of 10 to the x. Natural log is the inverse of e to the x. So let's just look at evaluating some of these just so you get comfortable with it. So in your calculator, these are in a scientific calculator. So log of 5 really means log base 10 of 5. Your calculator will just have the log key. So you would just do log of 5, and we're going to round it to the nearest thousandth, so 3 decimal places. So you should get 699 or 0.699. So really what this is 10 to what power gives me 5. So whenever the base isn't there, it's 10 to what power gives me 5. So same with this one. 10 to what power will give me 17.12. So I take the log of 17.12. So again, remember there's really like a little base 10. You get 1.234. ln of 5, remember, is like saying log base e of 5. But you have ln as a button on your calculator, which automatically is doing log base e. So it's asking e to what power is going to give me 5. And the answer is 1.609. Same with this one. So this is like saying log base e of 0.1. So put that in your calculator. It's asking you e to what power gives me 0.1. The answer is negative 2.303. So the question is, what happens if you have a log where you don't have base 10 or base e, so you don't have a button for it in your calculator? How do you go about evaluating it? So that's where this change of base property comes into play. So basically, let's say I have log base b, which b can be any number, of a. What you would put in your calculator is typically we would use base 10 because we do have that button in our calculator. So see how we keep the bases the same? Typically, it would either be base 10 or base e, so that you could either use a log button or you could use the ln button. And all you do is you take the log of whatever you're trying to find the log of, but because it was a different base other than 10, you divide by log of that base. So what this ends up being, so let's just look at an example. If I have log base 3 of 5 and I want to enter that in my calculator, I'm going to do log base 10 of 5 over log base 10 of 3. So it's easy to remember because it's always the bigger one divided by the smaller one. So log of the bigger one divided by log of the base. And remember, you pick a base. You can pick any base to do this formula. I could pick base 2 if I want, but it would be kind of silly to do that because you can't do log base 2 in your calculator. You would then have to do change of base again for the top and the bottom. So it's convenient to use log base 10 because what this really ends up being is log of 5 over log of 3, because remember we don't really need that base 10. It's these two things are equivalent. So then you would put that in your calculator and you get 1.465. You could also do this using natural logs. So what happens if I pick E to be my common base that I'm going to use? Which that's totally fine. So this is like saying the natural log of 5 over the natural log of 3, which in the end you'll get the same answer. So you pick the base, but you want to make it convenient because you want to be able to plug it in your calculator. So it's either base 10 or E so that you can enter it like one of these two things in your calculator. You do not need to show this first step. I just wanted to show you that how I'm making M either 10 or E, depending on what I want to use at the moment. It doesn't make any difference. You get the same answer. So that leads us to the last thing here, which is looking at some more special log properties. So if we go to the next page, we have several different properties, and if you just remember that logs are really exponents. So when you're thinking about the log, you're asking yourself, what do I have to raise to this power to get out this number? So when I look at this first one, I'm asking myself, b to what power is going to give me 1? So this was really asking myself, b to what power equals 1? And the answer is b to the 0 is going to equal 1. This next one's asking me, b to what power gives me b? So the base is b. How do I raise this to a power and get out b? Well, you're going to raise it to the first power. So the log is equal to 1. The next one, b to what power gives me b to the x? Well, it's going to be x. And this one is a little bit different. This one's just going to equal x. So it's a little bit different because it's b raised to log base b of x. So what happens is the b and the log b end up canceling out, so you're left with just an x. And that's going to be something that we're going to use when we start solving equations. Over on this side, we have natural logs. So I'm just going to rewrite these just so you can kind of see as log base e. So I'm doing log base e of 1 really asks me e to what power equals 1. So e raised to the 0 is going to get me 1. The next one here, log base e of e, is really what you're trying to find. So e to what power gives me e to the first. So this is actually going to be something we're going to see a lot of. ln of e is always just 1. And then this last one here, log base e of e to the x. We're trying to figure out what that is. So e to what gives me e to the x? And the answer is just x. So those are looking at the properties. So now let's actually try these examples where we're going to use these. And just going back, some of them are going back to just understanding what a log is. So for A, I'm going to just write them down here. Log base 2 of 8. Again, remember what this is really asking is 2 to what power gives me 8? What's the exponent that I need to raise base 2 to get 8? The answer is 3. Remember, you could also think of this as log base 2 of 8 equals x, and then you can drop the log and swing the base like we did last time. So 2 to the x. So then you rewrite 8 as 2 to the third. So then you see that 3 equals x. So same idea. It's just really, for these, we're just really trying to understand what these different properties are. So that's using this idea is gonna come more into play when we get to these later ones. But for B, again, you can decide how you want to do this one. If you want to set it equal to x, and then solve it like an equation. Or if you want to think about it in terms of the definition, 10 to what power gives me 10,000? So the answer is going to be 4. And then when we get to C, D, and E, though, you're going to have to use these log properties. So log base B of B, so B to what power gives me B? This is up there, up in the special properties. But B to what power gives me B? Well, B to the first. And then we have D, log base B of 1 equals, so again, B to what power gives me 1? B to the 0. And then the very last one, letter E, we have log base 4 of log base 5 of 5. And we're trying to figure out what this is. So for this one, you're going to want to simplify this section first. So we're going to do log base 4. And in parentheses, remember this is like saying 5 to what power gives me 5? So the answer is to the first. So this is really just going to end up being 1. And then you ask yourself, okay, 4 to what power gives me 1? So 4 to the 0. So this ends up just being 0.